Imagine discovering something nearly the size of a continent, hidden almost 2,000 miles beneath your feet. For centuries, humans have mapped the surface of Earth, explored the deepest oceans, and even sent spacecraft beyond our solar system. Yet one of the greatest mysteries may have been hiding inside our own planet the entire time. Using powerful seismic technology, scientists have detected two enormous structures buried deep within Earth's mantle. These massive regions are unlike anything researchers expected to find. They're denser than the surrounding rock, incredibly ancient, and so unusual that scientists still debate exactly what they are and how they formed. Could they be remnants of Earth's earliest history? The remains of an ancient collision with another world? Or evidence that our planet's interior is far more complex than we ever imagined? Today, we'll journey thousands of miles beneath the surface to explore one of the most astonishing discoveries in modern Earth science, and why these giant hidden structures continue to challenge everything we thought we knew about the planet we call home. Part 1. Looking inside a planet no one can reach. No human has ever traveled anywhere close to Earth's core. In fact, the deepest hole ever drilled reaches only about 12 kilometers, barely scratching Earth's outer crust. Beneath that lies nearly 6,400 kilometers of rock, extreme pressure and temperatures hotter than the surface of the sun. So how can scientists study a place they've never visited? The answer comes from earthquakes. Whenever an earthquake occurs, it sends seismic waves racing through the planet. Just as doctors use ultrasound to examine the human body, geophysicists analyze these waves to create detailed images of Earth's hidden interior. Different materials affect seismic waves in different ways. Some slow them down while others allow them to travel more quickly. By collecting data from thousands of earthquakes across the globe, scientists have gradually built a three-dimensional picture of what lies far beneath our feet. And that picture revealed something no one expected. Part 2. A discovery hidden deep within the mantle. Deep above Earth's core, researchers identified two enormous regions where seismic waves consistently slowed down. One lies beneath Africa, while the other stretches beneath the Pacific Ocean. These formations are so vast that each spans thousands of kilometers. Together, they represent some of the largest structures inside our planet. Scientists call them Large Low Shear Velocity Provinces, or LLSVPs. The name simply describes how seismic waves behave when passing through them, but the name doesn't explain what they actually are. For years, researchers have debated whether these regions are hotter than the surrounding mantle, made from different materials, or perhaps both. New computer models suggest they may also be denser than nearby rock, allowing them to remain stable for hundreds of millions, or even billions, of years. Instead of being random pockets of molten rock, these structures appear to be long-lasting features that have influenced Earth's internal dynamics for much of our planet's history. Part 3. Why scientists believe these structures shouldn't exist. Earth's mantle isn't completely solid or completely liquid. Over millions of years, hot material slowly rises while cooler material sinks, creating enormous convection currents that help drive plate tectonics. Because of this constant movement, scientists once believed any unusually dense or chemically distinct region would eventually mix into the surrounding mantle. Yet these giant structures have remained remarkably stable. That raises an extraordinary question. Why haven't they disappeared? Some researchers believe they contain ancient material left over from Earth's formation more than 4.5 billion years ago. Others suggest they could include remnants of oceanic crust that sank deep into the mantle over immense spans of time. Another intriguing hypothesis proposes that they may preserve material from a colossal collision early in Earth's history, the same giant impact believed to have contributed to the formation of the Moon. While this idea is still being investigated and remains unconfirmed, it illustrates how discoveries deep inside Earth can reshape our understanding of the planet's earliest chapters. Whatever their origin, these immense structures remind us that Earth's interior is still full of unanswered questions. Even after centuries of scientific exploration, our planet continues to reveal surprises hidden far below the surface. One of the most fascinating aspects of these giant structures isn't simply their enormous size. It's the possibility that they have survived since the earliest chapters of Earth's history. Some scientific models suggest these regions may have existed for billions of years, making them older than today's continents, and perhaps among the oldest large-scale features still preserved inside our planet. Think about how dramatically Earth has changed over that immense span of time. Entire oceans have formed and disappeared. Continents that once fit together as a single supercontinent have drifted thousands of miles apart. Mountain ranges have risen, eroded away, and risen again. Countless species have evolved, while others vanished forever during mass extinction events. Yet far below all of these changes, these mysterious structures may have remained remarkably stable. That stability is one of the biggest puzzles facing geophysicists today. Earth's mantle isn't a motionless layer of rock. Although it is solid, it behaves like an extremely slow-moving fluid over millions of years. Heat escaping from the planet's core causes enormous convection currents that continuously move material upward and downward. For decades, many scientists expected that this constant circulation would gradually mix the mantle together, erasing any ancient structures. Instead, seismic imaging continues to reveal two massive regions that appear to have resisted that mixing process. Why? One leading idea is that these structures are slightly denser than the surrounding mantle. Even a small difference in density could allow them to remain anchored deep within Earth, while hotter material slowly flows around them. Recent computer simulations support this possibility, although researchers are still refining their models as new data becomes available. Another intriguing possibility is that these regions preserve chemically unique material, dating back to Earth's formation over 4.5 billion years ago. If true, they would act almost like a geological time capsule, preserving clues from a period long before the first oceans, continents, or even the earliest forms of life appeared. Some researchers have also explored another remarkable hypothesis. Around 4.5 billion years ago, scientists believe a Mars-sized object collided with the young Earth in an event known as the Giant Impact. This collision is widely accepted as the leading explanation for how the Moon formed. A few recent studies suggest that some material left behind by this ancient impact may have eventually settled deep within Earth's mantle, potentially contributing to these giant structures. While this idea is still being investigated and has not been confirmed, it demonstrates how discoveries beneath our feet may connect to some of the most dramatic events in our planet's history. Whether one of these explanations proves correct, or whether the answer turns out to be something entirely different, these mysterious regions continue to challenge our understanding of Earth's interior. Perhaps the most exciting part of this story is what it says about science itself. Many people imagine science as a collection of finished answers. In reality, science is a continuous process of asking better questions. Every improvement in technology allows researchers to collect more accurate evidence, and sometimes that evidence forces scientists to rethink ideas that once seemed certain. Modern seismic networks now record earthquakes occurring all over the world with extraordinary precision. Every earthquake sends waves traveling through Earth's interior, and every one of those waves provides another small piece of information about places no human has ever seen.